Before I forget, please mark your calendar. Your the test number one, it's going to be Wednesday, October 6th, chapter 9 only. It's open textbook from 9:30 to 10:45. At the end of the class, I'm going to give you more information about how you want to take the test, what you're supposed to do, and all of that. For now, just mark on your calendar that that would be the date that we're going to have the test. In regard to homework, I send you chapter 9 homework assignment. Please make an attempt to do it on your own. Do not use the solution manuals and copy it because you're hurting yourself, not anyone else. Even if you do it wrong, you still get the credit because you submitted. That's the important part. But it's a good exercise and good practice for you. And when I solve the problem, the day that's a due date, I will solve all the problems on the board and answer any questions and concerns you have. So you can see where you made a mistake, if you did. And you can correct yourself and you can learn from it. That's the whole purpose. Now, once you do the homework, please scan and upload it in Beachboard/Dropbox. And when you click on the Dropbox, you'll see a bunch of subfolders that I have created for you. The first one is a homework one. So you upload your homework before the due date, before 8 o'clock in the morning, because I need some time to take a look at it before I come to the class and just going over it with you. Even though I don't grade them, but at least I can see who's done what. And so if there is something catches my eyes, so I can just bring it up to your attention. So this is what you do. And when you scan them, please do not use pictures because pictures are a disaster for me. It takes a long time to upload them and print them, and it's a lot of problems. So most of your phone is a smartphone, and if you don't have this app, you can download it, but you can scan it with your phone. And if you have a scanner, that's even better. When you scan, try to scan all the pages in one folder and submit it, rather than scanning every page and ending up to submit like 10 pages. So I have to click in every one and look at every one of them. And it's just, time consuming for me. And keep in mind, I'm working for another company. We have a big printer here, but I'm not the only one working in this company. There are other engineers working, they need a printer. We have our accounting people, printing checks and all this. And so I cannot tie it on our printer for like 4, 5, 6 hours because of it. So if it's a simple, I can print them all in like, 15, 20 minutes, that would be perfect. I would be grateful.
So Professor, if we submit a multi-page PDF file, like a single file with multi-pages of our homework, that's okay?
Yeah, that would be fine.
Great.
Yeah, if you submit it in one file, one PDF file that contain all the pages, that would be perfect. Now, to my good friends that they don't live in the United States and they're still taking this course, in the United States, we have only one type of a paper that we use, and it is 8.5 inches by 11 inches. This is called letter paper. Do not use A4 because almost all other countries using that size paper. I do not have that size of a paper to print your your work, whether it's a test or a homework. And if you do it, save it like that, then a lot of your work is going to be cut off. And it's going to be very difficult for me to see exactly what you've done. So please be aware of that. When you're saving your file, make sure you save it on an 8.5 by 11-inch paper. So this way, I can print them out, I can take a look at them without worrying about, half of your work is going to be cut off because of, the different size of the page. So please be aware of that. That's just for people who they don't live in this country. And, I have few students that they still live in their own countries and still taking this course because the campus is not open. Hopefully when it's open, they're going to come here, then they won't have these issues. Now, again, we're going to talk about the test at the end of the class, but for now, I want to just go back to what we did last time. We talk about multi-stage breathing cycle when we have 2 compressors, 2 turbines. We have a small Q in and a very small Q out. So basically, we start the air at the first compressor. Because the temperature is too high, we have to bring it down to the same level at 0.1 in order to enter the second compressor. That's why we put an intercooler to cool it down. The pressure remains almost the same, but the temperature will go down. Once we get out the second compressor, now we have a very high pressure, high temperature at 0.4. Now I'm using this heat exchanger. Now, as I told you, in the industry, we call that heat recovery system. In your textbook, if you look at it, they call it as regenerative device. So I just want you to know that regenerative, at the end of the day, is a heat exchanger. No matter what you want to call it. Heat recovery system, regenerative. It's a heat exchanger that what we get out of turbine 2 at 0.9 has a lot of heat that instead of sending it out, we're sending it to this heat exchanger, so that heat is going to gain by 0.4 and 5. So the heat loss between 9 and 10 is going to be gained between 4 and 5. Now at 0.5, I have a very high temperature, very high pressure into the combustion chamber. Now, when I go to that combustion chamber, I'm going to use much less fuel. That's why my queuing is going to be much smaller. I run the first turbine, which is a high pressure turbine. Then when I get out, I'm going to lose the pressure, I'm going to lose some temperature. I cannot recover the pressure, but I can recover the temperature by reheating it. By reheating it, I bring it back up to like 0.6 temperature, and then I run the second turbine, which is a low pressure turbine. And that's how the system works. And the TS diagram for it from 1 to 2 is a first compressor. Then I lose heat, so I have to go down to get to the same temperature at 0.1 to 0.3. Then I go up to 0.4. Again, as you can see, it's the same temperature at 0.2. Then I continue on to 5 and 6. Then I go down to 7 for the first turbine. Then I reheat, that means going up to 0.8, same temperature at 0.6. Then I drop, going down for the second turbine, that's 8 and 9. Then from 9, I go to 10 and all the way back to 1. So my Q out is going to be between 0.10 and 1. And my Q in would be between 0.5 and 0.6. Now, since all these temperatures are the same, that means the H value at each point is going to be the same. So H1 is going to be equal to H3, because when we go to the table, we find the H value based on the temperature. H4, H2, H10, they're the same. H5, H7, H9 are the same. H6 and H8 are the same. So at the end of the day, even we have 10 points, we just look at the table to find 4 H values, that's it, not all 10 of them. Now, in order to find the values, the energy values, our Qing is a delta H cross the combustion chamber. This is our combustion chamber, H6 minus H5. As you can see, H6 minus H5. That would be our Qing. Our Q out would be H10 minus H1. Now, the work of a compressor and turbine. So the work of a compressor total would be work of a compressor 1 plus work of a compressor 2. What is the work of a compressor 1? Is H2 minus H1 plus H4 minus H3. Now, if you look at it very closely, H2 and H4 are the same. H1 and H3 are the same. So therefore, the total work of a compressor is equal to twice our work of a compressor 1. Simple as that. Similarly, work of a turbine total is a first turbine, which is H6 minus H7 plus H8 minus H9. Once again, if you look at it, H6 and H8 are the same. H7, H8, H7 and H9 also are the same. Therefore, the total work of a turbine becomes twice of the work of a turbine 1. So the difference between these two will give you a network. The difference between these two will give you a network. That never changes. As far as the thermal efficiency concerned, is basically network divided by Q in, or 1 minus Q out over Q in. This will never change. Now, if you look at it, before our Q in was from 0.4 to 0.6. That was a very large amount. Our Q out was between 0.9 and 0.1. That was a big one. Now what we did, we reduced this to smaller value. So my Q in is very small. My Q out also is small. So this ratio, if you look at it, becomes very small ratio. If I deduct it from 0.1, I will have a higher thermal efficiency. And that's the reason we do this. Any question? No question. Okay. Now, there are some issues that you need to know about this concept. And that is, I'm going to erase that because you don't need it anymore. You already know the test date, and we'll talk about it later. Now, the R of P is equal to P2 over P1, or P4 over P3 in this case. That's R of P. However, for the entire cycle, we call it overall pressure ratio. That means R of P overall. The R of P overall is not going to be P2 over P1 or P4 over P3. It's going to be square root of regular R of P, which is this one. So the overall pressure ratio for the entire cycle, since we have 2 turbines and 2 compressors, will be square root of R of P. If we have 3 of these, then it's going to be square cube of R of P. Depends how many turbines or how many compressors you have. If you have 2, that's a square root. If you have 3, that would be a square cube of R of P. So if the regular R of P is equal to 9, this becomes 3. If the regular R of P is 8 and we have 3 of them, so we have to use 3 here, then this becomes 2. So it all depends. We cannot do more than 3. And I'll tell you why right after this. So we cannot have 10 compressors and 10 turbines. It doesn't work that way. And it's just a waste of money and waste of time and waste of effort. So the maximum we can do, which usually it's done, is the 3 compressors and 3 turbines. Now, let me show you how this is done. Now, this information is not during a textbook. This is my personal experience I'm sharing with you. The compressors basically look like this. No. That's how compressors look like. You have the first segment, second, and third. So in reality, we don't have 3 compressors. We have 1 compressor with 3 segments. This would be a low pressure segment, mid pressure segment, high pressure segment. I'm sorry, high pressure segment, mid pressure segment, and low pressure segment. That would be your compressor. See if I made a mistake. Yeah, I did. Okay, never mind. It's my first deal was correct. All right. So that is the low pressure. This is the mid pressure, and this is the high pressure. So the air enters here, and we need very low pressure to run these blades. Then we get here, we need a little bit higher pressure, and at this point, we need much higher pressure in order to run the entire compressor. So in real life, when we talk about 2 compressor or 3 compressor, it's only 1 unit. Because it's impossible to put 3 large compressors next to each other. And the size of a turbine, each one of them, it's like the size of a VEC building. That's how big it is. So you can't put all 3 of them next to each other. The turbine is the opposite of that. So now the blades here on the turbine uses a high pressure because the blade is large and need too much pressure in order to run this blade. Then when I come to the middle section, which is a mid pressure, I need a little bit less pressure to run those blades. At the end of it, when it gets so narrow, then I have a smaller blade. So that's why I need very low pressure to run that. So when we're talking about 3 compressors and 3 turbines, it's actually 1 unit compressor, 1 unit turbine. It's not 3 of them, or it's not 2 of them. If it's 2, we have high pressure and low pressure. There is no mid pressure. If it's 3, we have a turbine with 3 different segments. So this is turbine, and this is the compressor. That's how they look like. So I cannot use this concept to do an equipment layout for you because you get confused. That's why I put 2 compressors and 2 turbines. And in reality, it's only 1 unit with 3 different segments. So that's just the FYI for you to understand what's going on as far as that. Any question on that? Okay. Now, the last part of the chapter 10 is jet engine. Now, jet engine basically this is how your jet engine look like. At this point, I have air this is the inlet. And that's exit. Now, in the industry, we call this diffuser. And this one is a nozzle. Now, at point 1, air enter, this is the compressor side. There are 2 sides of a compressor with an intercooler in between them. Then we get the combustion chamber. And we get to 2 sides of a turbine. And then, of course, we exit from here. Now, this is just exactly the way we just did the, I showed you the diagram. And basically, the TS diagram would be the similar that I just erased. Now, there's another problem when it comes to jet engine. Jet engine, when you're trying to generate power, which we call thrust, for the jet engine, there are so many other issues involved. And that is the number 1 issue is the aerodynamic. On aerodynamic side of it, since everything's in the airplane is designed for a laminar flow. So therefore, the cross-section area and inlet that cross-section area is very important. That will determine the velocity going in, the air velocity. At the exit, again, the cross-section of the exit, which determines the velocity of exit, becomes very important. Too much velocity coming in will create a turbulent flow, nothing is going to work. very low velocity, we have a laminar flow, but the turbine, the compressor is not going to function properly. And therefore, the turbine is not functioning properly, and we don't generate enough thrust. So it's a combination of aerodynamics and thermodynamics. Now, you guys have not taken aerodynamic courses yet. So it would be very difficult to expose you to solution to a problem because there are so many things that's unknown to you. In order to do that, I have to teach aerodynamic course first, so you know all the, idiosyncrasies of that, then combine it with a, thermodynamic in order to generate the power for that jet engine. So just for an FYI, I tell you how these things work. That's it. It's not going to be on your exam. It's not going to be a homework, nothing, just the general information. Now, just again, for your information, this is a wing of aircraft. The air will hit the wing of the aircraft and generate the lift. This is what we call lift in order to fly the airplane. Airplane go up in the air. Now, there are so many things involved in that. One, there's a drag force. The drag force, the airplane direction is this way. The drag force, keeping it up to go back. Then there's the friction of the skin of the wing and the fuselage. So that also have an effect. Then there is a weight of that airplane that keep pushing it down. So I have to create enough lift to keep the airplane up. That means my lift has to be bigger than the weight of the airplane. And I have to generate enough thrust. That's the power to compensate for the drag and friction so the airplane move forward. So this thrust will help the lift as well as moving forward. So as you can see, there are so many other things as far as the aerodynamics concerned involved that we need to address in order to design a jet engine. Jet engine is a very, very complicated piece of equipment. And that's why every time the aircraft is stopped in an airport, the mechanics go and check the engine, make sure everything's fine, there is nothing leaking or nothing's missing or nothing's fell apart. Because otherwise, the whole airplane will come down. Now, in order to take off, most of the aircraft use somewhere between 30 to 40% of their fuel just to take off. Because you're on the ground and you imagine an airplane like a 747 with all the 400, 500 passengers, the luggage and everything, and it wants to just take off. They have to have a lot of thrust. And that's why airplane, if you've been in an airplane, you know that makes a lot of noise to just run, and it takes a while before that air will generate the lift to take the wing up, and then the airplane starts going up. Once you go up, you glide, and your thrust will just work to cruise going from point A to point B. Landing is easy because you don't need too much thrust, because you throttle back down and reduce the speed, and you flap, the wings, and then just come down and slowly, and then you land. But taking off is the most difficult part of it. So that's just the general information for all of you to know. And that's how the system works. By the way, this is point 2, 3, 4, 5, 6 would be going out. So this is basically the jet engine. Again, beside the power plant is the aerodynamic side of it involved and all the equations that you need to consider. Keeping the velocity in a certain way, cross-section area at this point has to be a certain way. Same way here, in order to make this jet engine work. So that is basically outside of your ability, and that's why we're not going to get into it. Have any questions on them? All right. Now, let's talk about the exam. Now, you will have 3 questions. Diesel cycle, definitely. Actual braking cycle, definitely. Now, the third question going to be either auto cycle or man-made cycle. You remember we did that on the board? You guys give me information and I drew the TS and PB diagram for it. So watch out for this. I gave you a homework assignment that there's a man-made cycle in it. So you're going to get exposed to it. I'm going to solve the problem here. Then you know how to approach that. So that's going to be the 3 questions. Again, I said it so many times, you probably are bored by that. But the key to taking this exam is not sitting down and memorizing anything. You don't have to do any of it. Because it's open textbook, you have access to all the quote-unquote equations, which we have just a few. The rest of the relation that we built. And as long as you know the concept of diesel cycle, how it works, and braking cycle, or auto cycle, you're in good shape. Now, key to that is making sure you read the problem very slowly and carefully. Please do not be concerned about your answers. I don't care. So I'm not looking for accuracy of your answers. I'm looking to see how you're approaching solving this problem. That is 90% of the work. That is more important than finding the actual exact answer. If you have made a mistake in the calculation and you have a lot of crazy answers, I give you the credit for all the work you did minus that portion. Not saying, okay, you have a wrong answer, so you get 0. No, that's not how I grade your paper. So pay attention to that, read the problem carefully, do it the way I do, organize yourself, write down all the given information, what you need to find. from a step 1 to 2 to 3 to 4 and so on. Don't jump from one to another one because you're causing yourself a headache and a problem and you get more confused. Now, the second thing is preparation. You need to prepare everything. For instance, if you do not have a textbook and you have an ebook, make sure you print the tables that you need. Those tables are A17 and A17E. You may want to, also print table A2 that has values of CP and R and all of those things. So that's the point. If you have a textbook, make sure you tap those tables. That saves you a lot of time. You can easily go to that table by just pulling, the tab and just get to that page rather than going back and forth. In the textbook, the chapter 9 section, tab the auto cycle, put a little tab on a diesel cycle and tab on a braking cycle. So in case you forget something and you want to take a look at it, you can access it very quickly. That's called time management, preparation. Second thing about time management, this has been my experience every semester. When we were at the class, I was watching people. They spend 45 minutes to solve the first problem. They insist to finish it. That's a wrong approach. Read all these 3 problems. Find the one that is easy for you. Start with that one. There is no rule that you have to solve the first problem first. Start with problem number 3 if you're comfortable, or number 2, or whatever it is. If you get stuck for whatever reason, let it go. Continue. Finish the rest of it. Then go back to the problem that you got stuck. If you still can't figure it out, at least you have the credit for all the other work. But if you stay there and insist to finish the first problem, then you run out of time. You don't have enough time to do the second and third problem. Then become a disaster. Just avoid that. If you remember from the beginning of the class, I told you I don't want you to be a student anymore. Think as an engineer, behave as an engineer, work as an engineer, and try to solve a problem as an engineer. Step outside the box, look inside, and try to do what you think is the best possible way of solving it. If you read the problem carefully, you always find the easiest solution. This test that I'm going to give you is designed that you can do it in 35 to 45 minutes. If you are prepared. If you're not prepared, you can have all the time in the world and still not be able to do it. One of the things, when we had an in-person class, people were reading the Brayton cycle while they're taking a test. You can't come in and take a test reading the chapter, see what the Brayton cycle is all about. You're supposed to know that. You're supposed to be prepared. So don't hurt yourself. Do your study. You don't have to study hard. You don't have to stay all night, up and banging your head against the wall trying to memorize anything. None of those. If you study and know each cycle principles or characteristics, if you will, then you're in good shape. You don't need to have anything in front of you because you know the principles, the basics, the fundamentals of each cycle. That's the key. You know that, you can do the TS diagram, you can do everything. If there are efficiency given, which definitely is going to be there, Make sure you show that on your TS document. And make sure you include it in your calculation. You miss that, you lose a lot of points. Small things that you need to pay attention. If the problem says that consider CP and CB variable, that means they are not constant. Don't write down that I assume they're constant, I'm going to solve it this way. And as I mentioned before, do not mix and match. You can only solve the problem thermodynamically or heat transfer, which is the temperature. You can only do the temperature if CP and CV are constant. If not, don't even bother with it. So pay attention to those little details. That will help you a lot. Again, if you want to study, all you need to do, go back to your homework, redo it again, take a look at it. Look at the examples in chapter 9. Cover the solution and do the example on your own. And then check, see if you're correct or not. That's how you can study. And the whole thing take you about a couple hours, not too much. So you don't have to kill yourself for this test. Test is going to be very, very easy. It's like 1, 2, 3, 4, you're done. That's it. Unless you decide to make it hard on yourself and go out of your way to make it hard, then there's nothing I can do. Now, your time is 9:30 to 10:45. This will give you 75 minutes to do the test. What I'll do, I will email you the test at 9:15. So that I give you 15 minutes so you have a time to go and print the test and have it ready. Then from 9:30 to 10:45, you do the test. Then I also give you another 15 minutes until 11 o'clock to scan your test and submit it in a Beachboard, Dropbox, subfolder test 1 by 11 o'clock. So you have 30 minutes extra time. In reality, now you have 105 minutes. 1 hour and 45 minutes. That's what you have. Instead of 1 hour and 15, now we have 1 hour and 45 minutes. We have plenty of time for the test that you can do it in 45 minutes. Let's say you do it in 1 hour. You still have a 45 extra minutes. Now, part of the preparation, make sure if you have a printer at home, it's working. Your printer has ink, you have paper, you have everything. Don't wait on the test day and then shoot me an email. Oh, I don't have, my printer doesn't work. What should I do? Now, since we have a hybrid school right now, some of you may be taking the hybrid courses, you are allowed to go to school, especially if you're vaccinated. And if you're not, you have been tested, you can go to school and use the printer at the school. The printers, the scanners, all the devices at the school. So you can use that. Now, last year, the school was completely closed. That was a different story. Now, if you're working somewhere as an intern, You have access to printer. You have access to scanner. You can sit down at your work and take the test there instead of sitting at home. Or you can go to school, take the test at school and submit it there. So that comes all to preparation, how well you prepare. Keep that in mind. If you submit, because when you upload your homework, your test, Beachboard will put a time. I know exactly what time you submit your homework. If you submit a homework at 11:01, I will not grade it. That means you get 0 for your effort because you were 1 minute late. I have heard in the past 3 semesters that we're doing an online, course, all the excuses. Oh, my printer went out, or my Wi-Fi, I lost it, or oh, when I scanned it, this file became 28 megabytes and I couldn't upload it. I mean, all kind of excuses to basically justify them being late. And I heard it all. The first day of the class, what did I say? I said, you're not a student anymore. I treat you as an engineer with a fully 100% trust. And I want you to start thinking as an engineer. If you do that, again, you have no problem. But if you stay as a student, crunching the numbers, that's all your focus, I can guarantee you, you'll make a lot of mistakes, you're going to be late, and then at the end, you're going to leave a note embarrassing yourself. I ran out of time. What do you want me to do? Give you credit for that statement you made? You just embarrassed yourself. Not only that, that's insult to my intelligence when you write that. So you're insulting me at the same time, you're bringing yourself down, disrespecting yourself. Do not write any of those things. Think as an engineer. Be an engineer. That's it. Practice that. That's your future. You cannot, when you graduate, you cannot tell your client that, well, I ran out of time, so I'm sorry, I don't have an answer for you. That's not how it works. You're constantly going to deal with the deadline, and that's the way it goes. In my 37 years career, I never, ever asked any of my clients for the extension to do the project. Not only that, every project that I was involved when I did throughout my career, I finished it ahead of the schedule. That's why my client worship me, because they know that I can deliver, and I can deliver before their deadline. I have to kill myself doing it, I do it. That is the sign of a good engineer. Procrastinating, there is no place for you. For those of you who come to the class in the last second, I'm sorry. I'm going to be blunt with you. You're not going to have a good career once you graduate, because you're going to keep procrastinating. You're going to keep being late, and you think you can get away with it. You may get away with it at school, but you think in real life you can get away with that? You're supposed to go to a meeting at 8 o'clock, you show up at 8:15, and you think everybody's going to go, oh yeah, that's okay, no problem, you're 15 minutes late. It doesn't matter what kind of excuse you're going to come up with. You can say that, hey, I was driving on the freeway and a 747 landed on the freeway. That's why I had to wait until they cleared the mass. That's what I was late 15 minutes. You can even use that as an excuse. So stop coming up with excuses for your misbehavior. Only way you can survive in the future is being on time. And if you can do it ahead of the time, if you can go to a meeting 5 minutes before the meeting starts, you're going to be a hero. But if you come in to a meeting 1 minute late every time, people are going to hate you. Oh, we still have to wait for John to show up. You can't start a meeting because John is not here. You can't do that. So be very conscientious of that. Don't complain. Don't send me an email. Don't send me a text with your problem while you're taking the exam, because I do not respond to it. And if you're late, I don't care what kind of excuse you have that shows that you were not prepared and you're late, therefore you don't deserve to get a credit. Because I'm not going to make an exception for 1 or 2 students while the other 34, 35 students did their work, submitted on time. Why should I punish them because you were late? No, you were late, you should be punished. They deserve the courtesy, they deserve my respect. So I hope you all understand that. I'm not trying to be tough, I'm not trying to be a jerk. You might consider me as one, that's fine, that's your opinion. I'm just trying to make you change your attitude and start thinking as an engineer. That's all I'm trying to do. Now, if you have some issues, problems, or you cannot have access to a printer, whatever reason, contact me before the test, and I will show you what you can do. I'll find a way to work with you. That's what I'm here for. So don't forget that. Let's see what else is we can talk about. Do you have any questions as far as the exam concerned? Wow, that's interesting. Usually a lot of people have questions, but you guys don't. That makes me happy. Okay. All right. So that's how we're going to do the test. So you get email from me at 9:15 and you submit it by 11 o'clock. No later than 11. Try not to do it right at 11 o'clock because there is a chance you might be late for 1 minute. Try to do it before that. 10:59, 10:58. If you're prepared, you'll be done by 10:30. And you can go and relax and not to worry about it. Now, again, the questions that you're going to get not going to come from outer space. If I did not cover any portion of the chapter, you're not going to get any questions. If I did not solve example problem or homework assignment, you will not get any question outside of that. That means you're not going to get a question about our Carnot cycle. You're not going to get a question about Ericsson cycle, Stirling cycle, jet engine, or even modified Brayton cycle. You don't even get that. So I made it very simple. I'm giving you the hint. What are the questions? That should be very easy to study. Now, the most important part that I need to talk about is a trust. We started this course. I told you that I will respect you as an engineer, as my colleague, and I will have 100% trust on every single one of you. If you decide to misuse that trust and cheat, first of all, you're going to get caught because you think I don't know anything, but I do. I've been doing this for 28 years. And if you look at it, each year, 2 semesters, I also taught courses during the summer. And every time I had 30 to 40 students. So you can see that I've seen it all, and I've heard it all. And please, you came too far. You are pretty close to graduate, and you have too much to lose if you cheat. I give you an example, which is a very unfortunate example. I never experienced this until the last semester. There were 4 students in my 3 classes that I was teaching on a power plant design, all 3 of them. Total of 4 students that I caught cheating. And they thought they can get away with it. I gave them a break. I gave them first, for the first test, I gave them 30% of the grade instead of giving them a 0. And I had a one-to-one discussion with every one of them and asked them to, you got too much to lose. Do not do this anymore. Because if you do, you're going to get expelled from school. Comes to the second test. Exact all 4 students. They did the same thing. And the funny part, they admitted the first time and they admitted the second time. And they wanted another break. But it was out of my hand. I reported them to school. They got expelled. That's end of their career as a mechanical engineer. Because you cannot continue your study anywhere in the United States and anywhere in the world. Because you have to send your transcript, and guess what? In your transcript, it says power plant design, cheating, and expelled. That's it. You can't even go to any other engineering major with that in your record. So the only thing you can do if you want to have a bachelor's degree, you can change the major and start from 0, not transferring anything, and start from 0 in different majors, like economics, sociology, psychology, history, English, literature, whatever, but not engineering. They were crying, they were so upset. I said, listen, you did it to yourself. I have nothing to do with it. I was nice enough to give you a break the first time. Why did you do that the second time? And one of them said that we thought that you're not going to catch us again. That was very funny. I said, I caught you the first time. You thought I'm not going to catch you again? And why? Why did you do that? All these years that you worked so hard, you spent so much money on your parents or yourself to get here, now you have 1 semester or 2 semesters left to graduate. You shoot yourself on the foot by doing that. So in every problem that you're going to see, I have a hidden things in it. That's how I can tell who's cheating, who's not. It's not hidden information that you will not be able to solve a problem. No. It's something that I have hidden there that if you cheat, it becomes so obvious that you did it. So forget about doing that. If you look at the syllabus that I send you, it's a policy of the school. And it's written in your syllabus that if you cheat, you're going to be in trouble. Don't put yourself in that situation. It is really not worth it. You don't want to do that. You work so hard to get where you're at right now. And please, I'm begging you, don't put me in that kind of a position to make that kind of a decision. I hated that. Last semester, those 4 students just drove me nuts. I hated myself and I hated what they did. I didn't hate the students, but I hated what they did. They put themselves in a very, very bad spot. And I felt sorry for them. All their hard work went down the trash can just because they thought, well, nobody's here, nobody's watching us. You have other instructors that they ask you to take a test, opening your camera so they can watch you. You have other professors that they make arrangement to take a test in a certain place with a proctor available watching you. I'm not going to do any of it. I'm doing it based on trust. So I'm trusting you. Do me a huge favor. Return the favor. Trust me. I will work with you. It doesn't matter. This test is only 20% of your overall score. Last semester, I had a student. He was a very hard worker and studied hard, but he went out of his way to make the first test so hard that he got confused, and he ended up to get 36 out of 100. And he was crying that, well, I know material, I know all of that, but I mixed the braking cycle with a diesel cycle, so I did it this way or that way. And he was really upset, having the lowest score in the class. I told him if he is willing to work on it, I will work with him. And he can pass the course, even with that disaster, having a 36 point out of 100. He agreed to work with him in my own hours. And guess what? He finished the class and he got a B from the class. He made one mistake and he learned from it. And he was willing to learn, he was willing to listen and change his attitude. He did that, passed the class with B. He thought he was going to get an F. Passing a class with B, that was humongous for him. So even if you do bad in the first test, that's not the end of the whole day. Don't worry about it. If you do bad, I will talk to you one-to-one, tell you what you need to do to improve. And if you're willing to work on it, I can guarantee you, you have no problem passing the course. But if you don't, and you do bad on the second test, then that's the time I'm going to have a talk to you and say, listen, maybe you should drop the course and take it again. Because now you're in danger of getting, F, and you don't want to do that. I hope that will never happen. It happens a couple of times in my career that I had to advise the students it's better for them to drop the class rather than continue and getting a very bad grade. One other thing that is very concerning that a lot of you don't care about doing the homework because you say, it's only 10%. I will do good on the rest of them and I won't going to get an A out of this course without doing any homework. You're wrong. The homework is a 10 points out of 100. You don't submit it, and if you don't get it, don't call me when you see your grade. Well, I got, 87, and I still got C because basically, that's a wrong example, but just, or I got 81, I got C, or 79, I still got C. Why? You didn't do the homework. And the way I grade you based on the curve, wherever the breakdown is on the curve, this group that are all together, when you get A, this group that are all together, when you get B, and the next group get a C, and the one that is way out there, when you get D or F. So sometimes 1 or 2 points will affect you to jump up to the different group and get an A rather than getting B, or getting B rather than getting C. So think about it that way. However, your choice. I'm not forcing you to do the homework. I'm just giving you the do's and don'ts. You make a decision. You decide whether you want to submit the homework or not. If you decide not to, let's see. Wow. Say that's another problem. We are missing 9 people in the class that they didn't show up. Now, they don't know anything about what we discussed, and then they're going to have a problem on the exam time. But they did it to themselves. Anyway, that's about it. Keep in mind, come next Monday morning, we're going to start chapter 10. We're not going to stop until you submit the homework and you take the test and then go to chapter 10. So we're going to continue. We're going to start chapter 10, which is going to be totally different of what you have learned on chapter 9. It's more interesting, less headaches, and less things to worry about. But it's chapter 10, it's basically the bread and butter of the whole power plant design. We'll talk about it and you'll see that. So, be ready for next Monday. In the meantime, if you have any questions, concerns, feel free to call or actually text me or email. You take care of yourself, and I will see you guys on Monday. If you want to stick around, talk to me, stay on. If not, have a good weekend, and we'll see you next month. Take care.
Thank you, Professor.
Thank you.
Have a nice day, Professor.
Thank you. No problem.
I had a question about the multi-stage Brayton cycle. So we have the TS diagram, and I was wondering if so when we draw a PV diagram, is that mostly to determine if we're using H or U, or should we always also draw a PV diagram in addition to the TS diagram?
Now that for the breaking cycle, you need only TS diagram. You don't need a
Okay.
because there is no constant volume process there. That PV diagram will help you. The breaking cycle is pretty easy and straightforward.
Hmm.
You already know that two of the processes, regardless of the cycle, chapter 9, 10, 11, compression and expansion is isentropic. The
Mhm.
other two, in case of the auto cycle, both of them were constant volume. So you needed a lot of U values. In case of a diesel cycle, one process was constant pressure, one process was constant volume. That's why the PV diagram will help you more than the TS diagram on diesel cycle. On breaking cycle, you have two isentropic and two constant pressure. There's no other things, so you don't need PV diagram. They're not going to help you. So that's all you need. It's a TS cycle.
Oh, okay. So yeah, so we just need to kind of remember which ones have constant volume and or which cycles have constant volume. And then I guess for the man-made, we have to have the PV diagram because we don't know.
Exactly. If you
Okay.
have it, again, if it's auto cycle, you need both TS and PV diagram.
Mhm.
If it's diesel cycle, TS diagram not going to help you. You need only PV diagram. If it's breaker cycle, you need only TS diagram because PV diagram is not going to help.
Mhm.
There is no constant volume on breaking cycle. So you need to think which one is the best that help you to solve the problem.
Okay.
If
Got
it's auto cycle, you need both of them to help you.
Mhm. I think it's like easy for me to draw the TS diagram, but a little harder for me to draw the PV diagram, like based on the TS diagram.
Why? Why?
Um,
It shouldn't. It shouldn't be that case at all. And I'll show you why. When you're doing a diagram, processes are known. These are isentropic. That's known to you. Now, if you have isochoric here and isochoric there, that means you need a PV diagram. That's the PV. This is auto cycle. You have process 1 to 2. The isochoric is process 2 to 3 and 4 to 1. So here's 2 going up to 3. V2 is equal to V3. That's the definition of the isochoric. Here, V1 is equal to V4. Again, that is the definition of the isochoric. Then you connect them together. Not much difficult. Let's say if this was isobaric. This is a case of what we call diesel cycle. In that case, again, the PV diagram, isobaric 2 and 3, constant pressure. 4 and 1, constant volume. That's 4 and 1. V1 is equal to V4, P2 is equal to P3, and that's all you need to do. These two are isentropic.
mhm.
So
Okay, that makes sense.
all you need to do, look at the processes and draw the diagram based on the process.
Mhm. Yeah, I guess I just need more practice. I always have a hard time figuring out where the one goes, like where to start it. And I guess it makes sense that like
Well,
low
again,
volume or high volume, low pressure
Yeah,
as
you don't
one.
have to start from point 1 to do the PV diagram.
Mhm. Mhm.
All you need to do is just watch the process. If you're a PV, these two is not going to help you because you don't have a temperature and entropy in this one. So
Mhm.
the one that will help you on a PV are these two processes.
Mhm.
2 and 3, constant pressure. Just draw a line with a constant pressure right there. 4 and 1, constant volume. 4 and 1, constant volume. Then connect them. These are your rising top. That's it. You don't have to start from 1.
Got it. Yeah, that makes sense.
Okay.
One other question. So for the isentropic properties, or the isentropic like parts of the cycle, how do you know like the curvature? Like, is it a upwards curving or downwards curving,
Well,
or
it
does that not
does.
really matter for us right now?
No, it is matter. Because look at it from 1 to 2.
Mhm.
1 to 2. 3 to 4. From 1 to 2, you're going up. Look at it. I'm going up to point 2.
Mhm.
3 to 4, I'm going down. This is my direction. It's always clockwise. So,
Yeah, well, I guess the curve I thought was like more the how quickly it gets there versus like how much it gets there.
no. Don't worry about
Oh,
that.
okay.
Because we're not talking about accuracy. There's no accuracy in this curve.
Mhm.
The only thing you're concerned to show the processes.
Mhm.
None of these accurate. There's no dimension on them. There's no accuracy involved.
Yeah, got it.
This is very arbitrary. Keep in mind, all these diagrams that you see, actually it's a 3-dimension.
Mm.
And we're trying to show it in 2 dimensions. That makes it hard.
Oh, okay. Got it.
So just be aware of that. From 3 to 4, you're going down. So that's the direction. You cannot go the other way because you're not doing it. Or
Can I
here,
ask what the third dimension is? Is the time like as another axis?
well, the axis is a time. Yes, of course.
Okay.
So in this case, you cannot go the other direction because it doesn't work.
Mhm.
Exponentially go up, and you did. Exponentially going down, and that's what you did.
Okay. Okay, got it.
Simple. Don't make it hard for yourself. Don't try to read into this too much.
I think as we're learning, we don't
Yeah.
know what's too much.
Well, the thing is, if you make it simple for yourself, it's going to be simple.
Mhm.
If it's hard, it's going to be hard.
Yeah.
Again, if you remember, I said as an engineer, we need to find the easiest way and the simplest way to solve the problem for our client.
Mhm.
It's not your job to read into too much details. If you're a manufacturing company making an automobile, and I come in and I say, I want something like a Volkswagen, design that for me. And you come back and give me a Rolls Royce instead, hey, I'll be happy, but I'm not going to pay for it.
Mhm.
I'm just going to pay something similar to Volkswagen, not the Rolls Royce. It was your mistake going to too much details and giving too many fancy things and give me too much room and too much power so I can have a Rolls Royce in my hand.
Mhm.
Ask you to do that. So you stay within the limitation that you have. Don't go overboard. Don't try to read between the lines. You're not helping yourself. You're
Yeah.
hurting yourself. Because by doing that, you're causing yourself to be more confused. Like you said, I have a problem, doing a PV diagram. Why should you have a problem doing PV diagram? It's very simple. Just follow the process.
Mhm.
Make it easy. Now, as far as how big these are or how small it is, who cares? As long as it's this shape, the rest of it is not important.
Yeah, I just wanted to make sure that I get this part correct because everything is based off of like these diagrams, like for the problems. So
Yeah, it's based on this diagram. This diagram helps you to understand what is going on so we can solve the problem.
yeah,
diagram will help you that this is a work out, this is work in, this is your Q in, and this is your Q out.
Yeah, as I started to do the homework problems, and it absolutely, I need to know, so I know which value, like H5, H4, like U2, I need to know like that, like, yeah, it holds all the information for you to set up your problem.
Once you do that, then you know that you need H3 and H2 to find a Q in.
Mhm.
You need U4 and U1 to find a Q out.
Yeah.
Because this is a constant walk. That's it.
Yeah, that's actually super, like, that's one thing I didn't understand in thermodynamics that I'm finally getting now, which is really helpful.
It simplifies, this diagram simplifies your work.
Mhm.
Otherwise, you have to find H1, U1, H2, U2, H3, U2, U3, H4, U4. You did all of that for what? At the end of the day, you need H3 minus H2 and U4 minus U1. You wasted your time finding all the other things that you don't even need.
Yeah.
Now, if I ask you to find the work of a compressor, then while you're finding a U1, you also find H1. Because you already found H2, so you need H1 to find the work of a compressor. Just find the things that you are asked to find. Don't go out of your way to do more things or find more values. Like a lot of people make a mistake. Here, you have V1 over V2, and you have VR1, VR2, and so on for this cycle. A lot of people find H1, U1, VR1, PR1. Why? You don't need that. You don't need this. It has nothing to do with the diesel cycle.
I think as we're learning this, we don't know what we need yet, so we just grab everything just in case.
No,
Yeah.
you're wrong. You're wrong. You know exactly what you need. You're not giving yourself a credit.
Mhm.
By doing this, you're writing that this is my Q in, this is my Q out. That's the value I need. Boom, boom.
Yep, got it.
And because it's a diesel cycle, I need only VR values because PR value is not going to help me. You don't have any relationship saying that V1 over V2 is a PR1 over PR2. There is no such a thing. VR1 over V2 is V1 over V2. That's it. So when you're dealing with an auto cycle and diesel cycle, you deal with a compression ratio, V1 over V2, and VR1 over V2, VR3 over V4. These are the ones that you worry about. When you deal with a Brayton cycle, there is no VR because you have P2 over P1. Therefore, you need a PR value. It's simple as that.
Okay, that helps a lot actually, because I wasn't actually sure when to use the PR versus VR, but that helps a lot. It's just cycle dependent.
The PR you use when you have a pressure ratio. VR you use have a volume ratio, which is we call it compression ratio. That's it. There is no relationship between compression ratio and PR. There is no relationship between pressure ratio and VOR. None of those. The relationship V1 over V2 is VR1, VR2, VR3. That's the relationship. If you have P2 over P1, then you have PR1, PR2, and so on. These two have a relationship, these two have a relationship. There is no relationship between PR1 and V1 over V2. There is no relationship on a VR1 with P2 over P. Absolutely not. So if you understand the cycle and characteristics of the cycle, you stay with that cycle, you got it made. You don't need to do anything else.
So can you explain how come the Brayton cycle like doesn't need the VR or the compression or the compression ratio?
Because there is no compression ratio.
Oh, because
The Brayton cycle works based on the pressure ratio only. That's the characteristics of a cycle. You cannot change that characteristic. Diesel cycle, auto cycle works on a compression ratio. That's their characteristic. Brayton cycle only works with a pressure ratio.
okay.
There's no volume or compression ratio involved in it.
How come there isn't a compression ratio? Because there's definitely compression going on.
This is your problem, my friend.
Mhm.
This is your biggest problem. You're reading between the lines. There is no compression ratio involved in a Brayton cycle, because if you bring that, then you don't have constant pressure processing. See,
Oh, got it. You need the constant pressure. Okay.
definition of a Brayton cycle is isentropic, isentropic, constant pressure, constant pressure.
Got it.
What is the volume there? There is no volume. Yes, you have pressure in diesel cycle. Yes, you do have pressure in, auto cycle. But you don't have a pressure ratio in them.
Because you need constant pressure to have the pressure ratio and constant volume to have the volume ratio.
Exactly.
Okay,
Exactly.
that makes sense.
So keep in mind, in a diesel engine, there are a lot of things happen that you are not going to get exposed to it because this is not part of this class. You study automotive engineering, then when you're going to learn much more detail about, diesel engine or auto cycle or heat engine or any other type of engine, that we're not even going to touch those things here in this class because it's not part of our job. So yes, there are pressure involved in a diesel cycle, but a different way, not as a pressure ratio. Yes, there are compression happen in Brayton cycle, but not as a compression ratio. That's what you need to draw the line.
Mhm.
What's happening there, excuse my French, is none of your business. There are so many other things happen there that if you want to get involved, then you're going to miss the big boat.
Mhm.
So don't do that to yourself. Try to just look at it the way we set it up. This is not a automotive engineering course. This is not a heat transfer course. This is not any other course or aerodynamic course. That's what I didn't talk about jet engine. Because if you want to get involved in all of that, then we need to study 3-4 years in order to completely talk about all of these things for one class. Can you afford to have that? Of course not. Again, once you decide what specialties you're looking for, if you decide to go to aerodynamics, then you stay focused on that. What do you care about what happened in a diesel cycle? What kind of a pressure they're going to use? Because you're not dealing with it.
Because it's interesting, I guess.
If you want to go to aerospace, you should care about what happened in the Brayton cycle and the effect of aerodynamics in the Brayton cycle in order to design a jet engine so it can fly the airplane.
Mm-hmm. But I get you can still need the other cycles if you have a piston airplane, right?
Piston.
Yeah.
Well, if you have a prop.
I guess that's not. Yeah, prop.
Yeah,
Not turboprop, I guess, just a regular piston
Yeah,
prop.
you just have a prop. The turboprop is just helping the air intake to go more laminar. That's it.
Mhm.
If you have a prop engine, it's a totally different engine.
Yeah.
But nobody that I know study aerodynamics and stay focused on the prop engine. Because the guys who design the engine are not the aerodynamics engineers.
Mhm.
They're manufacturers in some engine company, whether it's a 2 cylinders or 4 cylinders or whatever the case is.
Yeah.
The jet engine built by GE or ASEA or ABB, they call it, or Rolls-Royce. These are the 3 companies building jet engine.
Is Pratt and Whitney a big one? Or they're not big anymore?
Boeing and Airbus and all the aircraft companies purchasing it from them and just putting it there.
Okay.
So all the aerodynamic engineers working for Boeing, they're trying to put the airplane up in the air. They don't care what is happening in the engine because some other companies do. Having the knowledge of it is good, but you don't have to know everything. If you have an idea that as a mechanical engineer you should know every details, you're in deep trouble.
There's like too much to know.
Exactly. If you talk about gearboxes or clutches, I'm out to lunch. I don't know. I'm expert in my field. You're going to be expert in whatever field you choose in the future. 20, 30 years down the road, you get in my age, then you realize how good that is and how expert you are in that field. If somebody comes along and asks you about some other thing, say, hey, I don't know. That's why we have specialized people. If you have a heart condition, you're not going to go to see a urologist doctor. You go see a cardiologist. He spent his life studying, working, operating on heart patients. You want to see that guy, not some general practitioners. Yes, he's a doctor. He knows some general idea, but he doesn't know as much as the guy that's a heart surgeon or the guy as a brain surgeon. That's why we have different specialties in a field of medicine. We have the same thing in mechanical engineering and civil engineering. There are civil engineering that they do only land surveying. There are civil engineers doing the geotechnical. There are civil engineers that they're doing underground piping, gas piping, and all kinds of piping work. There are civil engineers that become a structural engineer to build the high rises.
I guess for me, my end goal is like, I want to design an airplane, but like my path has always been like, okay, well, I want to be a generalist. I want to know all about it. So because
No.
in the end, like I want to manage all the engineers that do it, but I want to know every part of it.
You cannot.
Okay.
Not only you cannot, you will not be able to do it anywhere. That's why we have a special field.
Mhm.
50, 60 years ago, an engineer was supposed to know everything. Today, we have a mechanical engineer that doesn't know anything about the pumps, anything about air conditioning, anything about engines, because he's specialized in manufacturing.
But the lead designer will need to know everything, right?
No,
Okay.
no, because you never, ever work by yourself.
Mhm.
You're always going to work in a group of other people. Those other people have their own expertise that they bring to the table. So, yeah, when I was at a younger age, I went back to school and got a degree in electrical engineering. Not to become an electrical engineer or work as an electrical, just have a knowledge, because I had to work with a power plant. I had to know once I produce the power, where it goes and how it goes. Just a general information for myself.
I mean, that's my situation right now. I have a degree in industrial design.
No, sorry. Your situation is different. You want to know the electrical and sit down, design the electrical part of it too. I didn't want to do that.
Mm-hmm.
I stay focused on my part, but have a knowledge back of my mind that I know how those things work down in the road. So if some electrical engineer say, oh, this doesn't work, I have a knowledge to say, no, I think it works if you look at it again.
Yeah.
I'm not going to design it because I don't have the capability. I never practiced that. So you as an engineer become one member of your group and you have one responsibility to do what you know, not designing everything. There is no one-man gang involved. You cannot design the airplane and the engine and everything and then fly it. It won't happen. It will never, ever happen.
Sounds cool though.
It is a real life, my friend.
Mhm.
In real life, you will be one member of a or 200, sometimes thousands of other people that they work on that project. There is no way that you can design all components of the engine for the airplane and then aerodynamically design your aircraft, put them together, and then be a pilot to fly it from point A to point B, all at the same time. It won't happen. Because you're going to make a mistake in one place and you're never going to take off, let alone. So that's what you need to stay focused.
Gotcha.
You won't be able to be a one-man engineer solving all the issues.
Mhm.
No matter how many years you stay in school, how many degrees you get in a different field of engineering, you will never want to make it. So stay in your field, stay on your ground, trust other people's capability to do their share, and you do your share. And once you combine it together, it's a happy ending.
Got it. Okay.
That's what you need.
Got it. All right, cool. I actually had one more question. At the beginning, when you were talking about like triple turbine and triple compressors, like that in a like I guess in a car engine, that can be for each individual cylinder, right? Like you can have 3 turbos, 3 compressors, like for every cylinder.
It's really not like that. You can't compare the two. No, it's not like that.
Okay.
This is totally different. What cylinder is doing is the work of a compressor. That's what the cylinder does. The pressurizing constantly air getting to fuel injection, rather than in the compressor in your gasoline.
Okay. That's what, so that was like, so when you talked about like, I guess having the 3 compressors, like 2 of the compressors are the turbos and then the third compressor is still like the piston?
There is no 3 again.
Okay.
You say there are 3 compressors. I show it as a 3 so you can understand it.
Oh, got it. It's the 3 stages.
It's a 1 compressor with 3 segments inside of that 1 compressor.
Oh, okay.
Or there is 1 turbine with 3 segments, high pressure, mid pressure, low pressure segment of a turbine.
Okay.
It's 1 unit. But it's my job to show 2 of them or 3 of them here so you can relate to it.
Mm-hmm.
Draw 1 turbine and go to a different section, then you're going to get confused And the TS diagram for that will, I mean, the equipment diagram for that won't even cover the board. I have to have 20 of these boards together in order to draw the diagram for that.
So in the multi-stage Brayton cycle, you have two compressors and an intercooler in the middle. That is one device, like,
It's one device. It's
Okay.
all within a one, the whole thing has every component in it.
Okay.
Jet engine has a compressor with two segments and intercooler,
Mhm.
two turbine and a reheat in it, and a combustion chamber in the middle. All of that compressed in that yellow engine you see in a big aircraft or fighter jets.
Mm. Oh, yeah, I get it mixed up with I guess like a piston engine, and I get it I forget that this is not a piston engine anymore. This is a continuous cycle engine.
Yeah, piston engine has nothing to do with this.
Mhm. Yeah, I think I confused myself when I was
Yeah,
thinking about the
that's it.
cycles.
That's why we call it gas powered cycle. This is gas turbine. It's a turbine, it's not engine.
Mhm.
It works with piston, turbine work with a high pressure compressor. Two different things.
Okay, cool. Oh, yeah, no, that was a great explanation.
Not a
Thank you.
problem. Not a problem. Miguel, do you have any questions?
Yes, just one quick question, Professor. If we don't have a printer for the midterm, would we be able to download it like to an iPad and then just send you the PDF document of the test?
Wait a minute. You are able to do what? Download it where?
Yeah, like if I don't have a printer at home, could I like
Okay.
download the test onto my iPad and then just solve the test there and then drop it off in Dropbox? Like solve the test on an iPad?
Okay. Can you do that and then convert it to PDF and upload it there?
Yes, from my iPad, I can convert it to a PDF document.
Fine.
That works? Okay, yeah, not sure if you wanted it completely like written,
No, no,
like
no,
on
no.
paper, or if like digital was fine.
No, digital's fine. As
Yeah.
long as I get one file showing all your, 3 questions and solution to those 3 problems, I don't care how you do it.
Okay, yeah,
It's
okay.
much easier because not too many people have iPad or be savvy enough to work on it. If you are good at it, why not?
Okay, so that was just wanted to clarify that. Yeah, thank you,
problem.
Professor.
No problem. That's easy.
Thank you very much, Professor. And
My pleasure.
Have a good weekend.
See you later.
thank you.